Good afternoon, everyone. This is Dave Amato from Roadway Design Office. I want to welcome everyone to the fifth presentation in our DDI design webinar series. Today's topic is multimodal accommodation. And once again, we have Brian Toombs with Burgess and Nyepel presenting. Brian's a national expert on DDI design and has worked on dozens of DDI projects throughout the United States. He's also very involved with the FDOT DDI review program. With that, I'll go on and pass it off to you, Brian. And Brian, if you could share your screen.
Yeah, I'm just, thanks, David. I cannot actually. It doesn't look like I'm a presenter on this one. Brian, if you can jump in and help me real quick.
Yeah. Here, let me.
Oh, got it now. Hold on one second. Hold on one second.
Okay.
A second here. Let's figure out what screen.
There we go.
Which one can you see?
I see.
That's the notes one. You want to swap it?
Yeah, I do. Give me 1 second.
Yes, swap.
Let's see if it's, nope, not that one. Give me 1 second. Sorry. Technical difficulties. You got to love this. That's the one I want, I think. All right. Tell me.
There we go.
Perfect. All right. Thank you. Yeah, you know that's going to happen eventually. So, well, thank you, David. So yes, this is the what would be the fifth installment of the Florida DOT DDI Design Webinar Series. So we have taken a stroll through DDI design in general, focusing on the overview, geometric design, sign and pavement markings, and traffic operations. So this one today, we're going to focus on multimodal accommodations. So we're going to look at pedestrians, bicycles, and even a little bit of transit. So this is the fifth of six. 2 weeks from today, we have our sixth and final one, which will discuss the plan detailing and the public involvement. So as David indicated, we have us two are presenting, David from Florida DOT and then myself from Burgess and Nyepel. A couple of housekeeping items that we get into. Hopefully, as you guys have jumped on, you'll notice you are muted upon entry. If you need to ask questions, and we encourage you, please do ask questions. Please do it through the questions dialog box. David, one of his roles will be to keep an eye on the questions. We will try to answer them during the show. If we start running tight on time, then we may have to defer those answers to later, in which case we'll get back to you with those. All right, so we have a pretty full agenda today. First, we want to talk about the pedestrians, including the benefits DDIs offer the pedestrians and the best practices for placing the sidewalks and the crosswalks. Then we want to discuss the bicycle accommodations, including the strategies for how to provide for them through the interchange to avoid the keyhole issue, which I'll explain what that is. Then we're going to very briefly discuss the transit options before wrapping up with a couple of slides showing the additional DDI resources that are available as you develop your DDI design. All right, so DDIs offer several benefits to pedestrians. First, because of the efficient traffic operations, we generally see a reduced footprint for a DDI when compared to a traditional diamond interchange. For pedestrians, this means that they're crossing fewer number of lanes to execute their maneuver. The intersections operate using two-phase signals. This reduces the pedestrian wait time and provides more green time for the pedestrians. Similar to roundabouts, pedestrians are only tasked with crossing a single direction at a time with pedestrian refuges built into the design, either in the infields or in the median, allowing for a much simpler crossing. And DDIs provide opportunities for separate paths for bicycles through the interchange, providing separation from the pedestrians and allowing for safer passage for them. DDIs do offer some challenges, though, that may need to be addressed. First, one option allows pedestrians to be placed in the middle of the interchange, as shown in this figure. Placing pedestrians down the center is against user expectation and needs to be intuitive and give the adequate protection for the pedestrians. There are situations where pedestrians would have to look to the right for approaching traffic when starting their crossing maneuver, which is different than a traditional diamond interchange. The grouping of allowable vehicle movements in the DDI, such as the eastbound through on the arterial, at the same time as a southbound to westbound right turn from the ramp, for example, may not be intuitive to pedestrians. Finally, DDIs can introduce situations where pedestrians must cross free-flow ramp movements. These challenges are certainly not insurmountable, but do require some additional care during design to avoid introducing safety concerns for all users. FDOT provides guidance on pedestrian and bicycle accommodations in a DDI in their DDI development design criteria. Pedestrian guidance is found in section 217.6. One thing to remember is to consider pedestrians early in the DDI design process, as the placement can affect the ultimate layout of the DDI. This will allow you to develop a balanced design that meets the safety and the mobility needs for all users. When designing a DDI that includes pedestrian accommodations, there's 5 key design strategies to think about during design. The first is to look to reduce the vehicular speeds in the vicinity of the crosswalks. One way to do this is to reduce the radius of the turning movements. Research has shown that pedestrians have a higher chance of survival if hit by a car when vehicular speeds are reduced. Second is to ensure that adequate sight distance is available for both the pedestrians and the vehicles at the crosswalks. The need to make sure that both can see each other before the pedestrian steps into the roadway to initiate the crossing maneuver. And I think that's the critical piece. A lot of times we focus on, can the vehicle see the pedestrian, but we also need to make sure that the pedestrian can see the vehicles approaching. Third, try to provide storage length sufficient to store the vehicles at the yield location to avoid backing up into the crosswalk, as you see here. We don't want pedestrians to try to cross a ramp around stopped vehicles. Fourth, provide adequate spacing from the stop bar for the crosswalk. Also important to locate the stop bar where it is expected drivers will actually want to stop. This becomes hard at times as drivers try to creep up to look for gaps in approaching traffic. Fifth, it's important to provide the appropriate traffic control at the ramp terminal. Different situations exist where the right turn, for example, could be a free flow movement, stop controlled, signalized, allowing right turn on red, etc. Understanding how these conditions impact pedestrian safety at your specific location is critical to the design. So one of the questions I usually field when discussing pedestrian accommodations is, where should the pedestrians go through the DDI? And there's 2 basic methods for routing pedestrians through a DDI. One option is down the center, shown in this exhibit. This image here shows a street view of a pedestrian path down the center. The other option is along the outside of the interchange, that is shown here. This image shows a street view of a pedestrian path on the outside of the interchange. Bridge piers may make placing pedestrians down the center impractical. This image shows a diamond that will be converted to a DDI. Notice the existing bridge pier. One of the advantages a DDI offers is the ability to gain more traffic capacity using the same or even less roadway width, which allows for the existing bridges to remain more often than not. However, when the existing bridges remain, so do the existing bridge piers. So for this example, could a sidewalk fit down the center around this bridge pier? If the number of lanes were able to be reduced in one or both directions, possibly, and is something that would need confirmed early in the design process. Placing pedestrians down the center of the interchange minimizes conflicts with the left turning vehicles by reducing the number of free flow ramps needed to be crossed. As outlined in the FDOT DDI Developmental Design Criteria, section 217.6.1, the center, or down the middle, walkway is the preferred option for a DDI in Florida for several reasons. First, walkways down the center avoid free flow left turning movements. Note the 2 conflict diagrams to the right. The top image shows the types of conflicts between pedestrians and vehicles for a center walkway, and the bottom image shows conflicts for an outside walkway. The 2 key conflicts are removed when implementing the center walkway, highlighted in red. These are free flow left turns from the arterial to the freeway where sight distance and vehicle speeds could create significant safety concerns for the pedestrians. Second, center walkways improve the line of sight between the pedestrians and the drivers. As the pedestrian approaches the crosswalk and looks to cross the roadway, there should be no obstructions between the approaching vehicles and the pedestrians. This allows the pedestrians to be fully visible as they cross the street. Then continue the remainder of their crossing maneuver to get to the outside of the roadway, outside the interchange. Finally, the center walkway is preferred in Florida when crossing from the median. Crossing at the signalized intersection is consistent with expectations, i.e. the pedestrians would look to their left first for approaching vehicles. So you think about a normal intersection as a pedestrian steps out into the road, their first direction they're looking for the oncoming traffic is to their left. And when they're in the median, it's the same thing. It's important to clearly define the walkway boundaries within the interchange area to guide the pedestrians to the proper crossing locations. These two images show well-defined cut-through walkways through the interchange islands between the ramps that clearly guide the pedestrians to the next crosswalk. This shows an example of a well-defined walk-through, cut-through walkway from the pedestrian's view. Notice the different colors used to differentiate the walking path in the interchange island area. The elevation difference between the two surfaces gives great ADA compliant direction. And the FDOT DDI developmental design criteria defines the cut-through walkways needed to be a minimum of 10 feet wide when there is an elevation difference between it and the channelized island. And the walkway should be aligned to provide a perpendicular crossing at the next crosswalk to reduce the crossing distance and the pedestrian exposure. When selecting the location of the crosswalks, several things need to be considered. First, drivers should be able to see the entire crossing, including the curb ramps, where the pedestrians can be waiting to cross. Also, the pedestrians should be able to see the approaching vehicles. This is especially important at the free-flow crossings. For situations where a DDI is over the freeway, the bridge parapet can be an obstruction, and this clear sightline should be checked closely. If a pedestrian is standing at the ramp shown in red, for example, this is the view they have of the approaching vehicles because of the bridge parapet. For approaching drivers, pedestrians can be hidden from view by this parapet. This makes it very difficult for a pedestrian to find an acceptable gap in approaching traffic to cross. For a DDI under the freeway, make sure the bridge isn't in the way. There are two important objects we want the driver to see as they come up to the pedestrian crossing. The first is a crossing with the appropriate signage as indicated by the left-hand line. Second is the pedestrian who would be located where this second line is pointed, or the right-hand line. And be aware of possible sight obstructions from any structure elements such as the bridge pier in this image. So as we've already discussed, avoid placing items that could block the sight line between the pedestrians and the drivers, such as a raised vertical barrier that helps define the eyebrow. For this DDI, the barrier is outside the sight line. If it would have been in it, one option would be to taper the barrier down or use a reduced height vertical face, such as a standard curve that can easily be seen over. Wherever possible, try to make the crosswalks as near perpendicular crossings as possible to reduce the crossing distance and the exposure of the pedestrian. Use judgment and understand the balance of the stop bar location, the clearance interval needed for the signal, and the crossing length. Also recognize the driver's tendencies. In the case of this crossing, making this a perpendicular crosswalk would have pushed the stop bar pretty far away from the arterial for the right-hand turn lane. Would drivers really stop that far back, or would they creep up to see the approaching traffic and possibly be sitting in the middle of the crosswalk? Position the crosswalks in locations where the expected speeds are reduced. When crossing the outside ramps, placing them close to the arterial as the vehicles are entering the curve is good for speed management as well as positions them in the area where the drivers are really looking. Pushing these crosswalks farther down the ramps gives drivers the ability to exit the curve and accelerate, as well as puts the crosswalk in a location where they're potentially looking over their shoulder at gaps in emerging traffic rather than focusing on the crosswalk itself. This strategy keeps the pedestrians in a more controlled situation. And as we discussed earlier, place these crosswalks far enough away from the yield line to avoid vehicles stacking back into the crosswalks. I'm sorry. Yeah, place the crosswalks, yep. The ramp terminal design is very important to the safety of the pedestrians. There's 6 basic types of traffic control options for turning vehicles from the exit ramp onto the crossroad that a pedestrian will likely have to cross against. First is the free flow movement into an acceleration lane or an auxiliary lane, where speeds could be an issue. In general, keep the radius tight to control speeds. Target no more than 20 or 25 mile-an-hour speeds for this movement to manage them. And ensure nothing obstructs the sight lines, such as vegetation or signs, to ensure pedestrians don't accept insufficient gaps when crossing. It's all back to making sure that you have adequate sight lines for both the pedestrians and the vehicles. The second type is a yield control with an acceleration lane or auxiliary lane on the arterial. For this, position a yield line ahead of the crosswalk to avoid vehicles queuing back onto the crosswalk if possible. Because this is a yield condition, drivers may be looking over their left shoulder at the approaching traffic rather than for the pedestrian looking to cross the ramp. Look for opportunities to increase the awareness to drivers of a pedestrian waiting to cross. Third is a yield control with no downstream acceleration lane or auxiliary lane. Similar to the previous scenario, position the yield line ahead of the crosswalk to avoid vehicles queuing back onto the crosswalk. Also, this situation again presents the concern that drivers are looking over their left shoulder for gaps in traffic rather than for pedestrians at the crosswalk. Again, look for opportunities to increase the awareness of drivers or to drivers of a pedestrian waiting to cross. David, I think there's a question there. Do you want to go ahead and answer that one?
Sorry about that. Regarding the recommendation to tighten vehicle curb radii to reduce speed at crosswalk, what sort of radius will be preferred alongside these islands? I found that lower radius turning roadways require much more pavement width to accommodate the WV62 FL design vehicle.
Yeah, I mean that's a great question, and truthfully, I know you hate the answer. It depends, but what I will say is it is a balancing act, and again, similar to roundabout design, where you are trying to manage your speed, your fastest path. This is a similar situation. One of the things that we like to see potentially in the DDI developmental design criteria, it goes into some discussion about curve widening. And where you place some extra pavement for truck turns. And it may be a situation where actually placing the additional pavement maybe to the left instead of to the right and allowing a truck to kind of steer into that curve a little bit later is an opportunity to keep the driver or keep the speeds down for a passenger car. But it is a challenge and one that you just kind of have to play with a little bit to see. And I would say make sure that you're providing only the pavement that's needed for the truck to make the turn. In other words, don't get really conservative. Think about how that truck's going to travel through that swath.
Yeah, yeah. I want to add that if it's a multi-lane, like 2-lane right or 2-lane left. We don't design for trucks going side by side, going through the right turn. So you would design it to allow the truck, you would design the widened pavement, the striped out pavement in between the 2 lanes, and you would allow either truck to take that, to use that area to turn, but they wouldn't have to be side by side.
Yep, yep, that's a great point. And like I said, it's a great question. And this is, one of the challenges that you always run into as a designer is balancing all modes of transportation. So vehicles, pedestrians, bicyclists, all that. All right, I think that's it for the questions right now. Keep asking questions if you want. We'll try to stop where we
That
can.
looks like we have another one.
All right.
Would a rectangular rapid flashing beacon be acceptable to assist in protecting pedestrians for the free flow movement condition?
Yeah, and David, that may actually be your a question for you. I can honestly tell you that is something we have used in other parts of the country. Again, just as a way, if at a minimum, of trying to get that more able to be seen, the pedestrian and the awareness of that pedestrian being there.
Yeah, what the pedestrian, the flashing beacons do is just raise the awareness to the driver that pedestrians are out in the crosswalk.
Yep.
So that could be an option if you're crossing that free flow left, to help raise the awareness of the drivers. The other thing is you want to avoid as many free flow movements as possible. So as Brian said before, taking them down the median, the middle of the roadway, will eliminate the free flow movements turning to the left onto the freeway.
Yeah, and I think that's a great point that we're going to get into here in the next couple slides. You have a lot of options for how to handle the ramp terminal design, and even sometimes as easy as you have a free flow movement into an auxiliary lane versus a yield condition into a situation that there is no auxiliary lane or acceleration lane makes a big difference from a pedestrian safety standpoint.
Yeah, one other thing to add too is that for the right turning vehicles coming off the freeway, in many cases that is signalized, so it would not be a free flow right.
Yep. So great question. But all right, so let's keep going. We're talking about ramp terminal design. The fourth option is a stop controlled intersection. So in this particular case, position the crosswalk ahead of the stop bar as expected, but recognize that often drivers may stop at the stop bar, then they may roll up in order to better see the oncoming traffic and find an acceptable gap. So in that particular case, we need to look at the right turn movement shown here. And if the drivers are rolling up to look for their gaps and if they're going to block the crosswalk, that can create a problem where the pedestrians are either waiting to cross or they're playing Frogger to cross the ramp while avoiding the stopped car. So we need to be mindful of where we're placing the crosswalk. And in this particular case, for that right turn, there's nothing that says that crosswalk couldn't be a little farther up and potentially put that stop bar up. So now we get into the signalized crossings. So the fifth type of control is a signalized intersection that allows right or left turns on red. Similar to the stop controlled intersection, position a crosswalk ahead of the stop bar. But again, often drivers may stop at a stop bar, then they may roll up in order to better see the oncoming traffic and find an acceptable gap when allowed to turn on red. This again can introduce a conflict between the vehicles and the pedestrians. And allowing the right turns on red introduces other complications for a DDI, not necessarily related to pedestrians, but overall driver safety. So allowing right turn on red introduces poor sight lines as drivers look over their left shoulder to find gaps. So this driver would possibly look over their left shoulder in this direction when really they need to be looking in this direction. So if the animation didn't quite work, basically what we're saying is if they're following the green arrow, that's their typical direction that they're looking at a normal intersection. But when you look at the red arrow, that's where they should be looking. And if they're looking at the green, this particular car may think he's got a gap and he may pull out right in front of that silver car that's coming across. So that is one of the concerns that we have with allowing right turn on reds or right turns like that. And so the final type of traffic control is really my preferred strategy when designing, and I believe it's FDOT's as well, is take advantage of the two-phase efficiency of the signal and don't allow the turns on red. So signalize it, but don't allow turn on red. Because this is a simple two-phase signal, there's still a lot of green time able to be allocated to the right or the left turn movement. So there shouldn't create excessive delays for these movements if you don't allow the turn on red. This creates a protected crossing for the pedestrians and takes away a lot of the concern that we just discussed. David, do you want to weigh in at all on that?
Yeah, I'm all for signalizing the right turns and making a no turn on red. I think it's a very good idea.
Yep. And I would extend that also to the left turns. Again, drivers don't typically even think that they could go on a left turn. They usually see a signal, they stop anyway. But putting the sign that says no turn on red is important. So the intersection angle is also a good way to control the speeds at the intersection with the arterial. So intersecting angles of 30 degrees may imply motorists can maintain a greater speed and that there may be an auxiliary lane ahead on the crossroad. Intersecting angles of 60 to 90 degrees imply that motorists should slow and possibly stop before executing their turn onto the crossroad. Anything that can be done to reduce vehicle speeds where pedestrians could be in conflict is essential to a pedestrian-focused DDI design.
Brian, you have time for another question.
Absolutely.
This one's about PED push buttons.
Mm-hmm.
Are there PED buttons in place for all of these PED crossings shown? Are these placed in the aisles?
Yeah, it's a great question as well, because that we have a couple slides towards the end. Actually not towards the end. It's only a few more slides from here, where we do talk about the pedestrian push buttons, because that becomes a critical piece of the design. In the cases that we were showing here, again, these were like these right turns. They're probably, they're likely in the islands or something. But there is a specific, distance, and especially when we look to cross pedestrians into the median, there's a specific location that you want to, and a specific offset from the two push buttons that you want to make sure you maintain to avoid confusion and to make it ADA compliant. So it's a great question. Normally it's you put them, in the island where you can, but make it to where it makes sense to the pedestrian that's approaching that ramp and that crosswalk.
Yeah, that's another reason why it's so critical and important to think about the pedestrian accommodation early in the design process, to make sure you're not stuck at the end trying to cram all these pedestrian facilities in there where you won't have enough room for the separation of the push buttons and whatnot.
Yeah, and that's a great point, because it gets really critical when we think about the overall design of a DDI, especially if you're placing pedestrian facilities down the center. There's a certain width that you need to maintain in the middle. So that's obviously going to position where your lanes are at. But where that median comes to a point at the crossover intersections is oftentimes where these PED buttons then would end up for these crosswalks, which we'll show a slide later that kind of shows that graphically. If that point is too narrow, then you may have to actually move, either widen the median or shift those crosswalks back away from the crossing, in which case now you've changed your clearance interval, you've changed potentially your design. So, that's one of those things, to David's point. We want to make sure that we know right up front whether or not we are accommodating pedestrians and bicycles through the DDI, and where we're thinking we're going to do them. Some of the earlier presentations that we've had in this series, we talked about geometric design. There was a flow chart. So hopefully you guys have seen these presentations. If not, the recordings are available. But that flow chart kind of showed this iterative process for how to design a DDI, and this is one of those components that incorporates that iteration. All right. So now let's talk about the entry ramp options. So there's two basic types of entry ramp options when leaving the arterial. So first is the free flow, free right and left turns with the acceleration lanes on the ramp. So this promotes higher speeds, so the placement of the crosswalk is critical. As discussed earlier, place the crosswalk closer to the arterial before its speeds get too high for the right turning vehicles. Also, placing the crosswalk closer to the arterial focuses the approaching drivers to the crosswalk. Pushing the crosswalk farther up the ramp puts the pedestrian in a location where drivers may be caught looking over their left shoulder for gaps in the traffic rather than ahead to the pedestrian crosswalk. The second option is the right turn yield or stop control. This promotes lower speeds, but again, watch the location of the crosswalk relative to the yield line to ensure vehicles don't stack up on top of that crosswalk. Now, a little bit to the questions that were asked earlier. We talk about pedestrian signals, and again, this is going to be focused more on the median section because you're going to have multiple crossings stacked up, if you will, in the median. When placing walkways down the center, the DDI information guide, the second edition that FHWA has put out, offers two strategies of where to place the pedestrian signals and call buttons. Either place the signals on the wider side of the median or separate them diagonally where push buttons consistently on the same side. So in this case, on the pedestrian's right side as they approach the crosswalk. So you'll notice the stagger, but as you're approaching the crosswalk, the push button is on the right side. And that kind of consistency is what you would expect. David, looks like we have another question.
Sorry about that. Let's see. What about using terminal imaging instead of push buttons? Thermal imaging.
Yeah, and that's a good strategy. We haven't done a whole lot with that yet, but I know that technology is out there. David, I don't know if you've seen that yet in Florida a lot.
Yeah, I'm really not familiar with that.
Okay. But I mean, it would stand to reason that would also be a good strategy, but it's something that I think is somewhat in the infancy stage. Paul, I'd love to hear more about what your experience has been with that, because I could see a lot of benefits to that. So with the pedestrian crossings in the median, we need to make sure that the crossings are ADA compliant and that the minimum 10-foot separation is provided between the pedestrian push buttons. This is difficult to do when the median is very narrow. And so in those situations, consider moving the stop bar back where the median is wider. But we need to be careful, as pushing the stop bars back will increase the clearance interval in the signal and reduce the efficiency. So it's back to that balancing act and why we really need to look at this early in the design process to determine what is going to be the best location for not just the crosswalks, but also the signal timing, the horizontal curvature, the tangent length through the crossover, and so on. And so this image here is an example of an undesirable installation of pedestrian push buttons, because this situation can be confusing in pedestrians because there's multiple buttons in the same spot, essentially, with insufficient storage at the ramps because of the narrow median. So more than two pedestrians standing here, they're literally going to be stepping almost on top of each other or outside in a roadway. And so this would be a perfect situation of pulling these curb ramps back towards the, into the fatter part of the median. All right, so David, I don't know if we have any other questions. It doesn't look like we do. I wanted to pause for just a second. There's a lot there with pedestrians, and there's probably still even more that we could have gone into. But I do know that
Yeah.
FHWA's guide does have a lot of information on this as well.
Okay, we do have another question here. Will there be guidance on assessing capacity of ped storage at a median since the split phasing will have pads waiting for green, say to the right, while pads from the left are looking to get from the crosswalk to the sidewalk? Let's see.
Yeah, I think what
That,
the question is, if I'm getting this right, you've got a very limited space. If
right.
depending on where this location, this crossing is relative to the nose of the median, and essentially, one of the directions the pedestrians are moving and the other one they're not, and then vice versa. It's because of because it's a two-phase signal. And just making sure that there is enough room in there, and there is some guidance, I believe, in the FHWA document that I'll refer here at the end, as far as kind of generally where or how wide of spacing there should be. Um, this is again one of those where, based on that space, that width, if you will, then I think you would want to make sure that you can pull it back away from the nose of the median to give yourself enough separation.
Okay. And define sidewalk or sidewalk the entire median between raised and barrier walls.
David, you cut out a little bit. I'm hoping it was you and not my internet, but um, on wider, I think the question on wider medians within DDI, should there be a defined sidewalk width, or can the sidewalk be the entire median between the raised barrier walls? David, I'll let you answer that first. What do you typically see, or what do you want to see?
Mm, yeah, I don't think we have a set standard on that.
Okay.
Um, I personally don't see, I mean, if you have this one, I can just define it to a smaller space. In my opinion, you could use the entire space that you have between the two barrier walls for pedestrians to get through there.
Yeah, I think, and again, I'm hoping, I don't know if the audience is hearing you well. Um, what what I like to see is, if you have the width and you have the availability, go ahead and use the whole width between the barrier. And the only reason for that is because, if you got a couple of wheelchairs passing each other, um, if it's there's a certain width that you want to have anyway, but if you have a little bit wider accommodations, I don't think that's necessarily a bad thing. Obviously, the question becomes, if you were to go, say, with a narrower sidewalk and not use the full width of that, what I'll call the Q-tip, if you will, that median, what are you doing when you're not putting concrete down for that whole section? Um, because now you got to think about maintenance. Are you putting grass? Are you putting stone? Is it just something that's not usable? So typically what you end up seeing is, a lot of times, it's just sidewalk anyway. It's not that excessive of a cost, and becomes easier to maintain. So
Can you hear me now, Brian?
yes, I can hear you better now.
Okay, I just got a message that my internet connection was reestablished, so hopefully that'll take care of the problem. Yeah, I agree with what you just said. I think it makes sense, if you have the space down the median, to use the whole thing.
Yep. And especially it comes into play if you have, if you have an overhead bridge and you've got bridge piers in the middle, then sometimes it's good to have that extra width, just because you may have the piers a little staggered. They may not be centered in that, in that full median width, and it gives you more play. So that's a great question, though, because sometimes that width can get pretty excessive. But again, I go back to, sometimes it becomes more of a maintenance issue. All right, so let's get into bicycle accommodations. And I think one of the things I always like to preface when I talk about bicycle with a DDI is don't overthink it. You know, the bicycles are still going to be on the right side of the vehicles through the DDI if they're got their own lane, they're traveling with the traffic. It just so happens that when they're across, you know, in the middle of the DDI or in the interchange core, they're going to be more in the center or in the center of the roadway, as you can see on the image on the left. So, you know, FDOT provides guidance on bicycle accommodations through a DDI in the DDI Developmental Design Criteria in section 217.7. And it outlines 3 possible treatments for bicycle accommodations. And the first is the marked bicycle lane, similar to what's shown here. And so what you see, the image on the right, this is a bicycle lane that is extending, you know, through or across the right turn. And so in this particular case, a little bit of green pavement was used to designate that bicycle lane as it continues then, you know, in between the right turn lane and the through lane. And the image on the left just shows you, here's a bicycle lane that is going through the DDI, but as you go across the freeway, it's towards the inside of the road, but it's still to the right of the traffic. And so that's why I always say, you know, don't overthink it, because that is a, you know, they still operate just as they would at any normal interchange. David, looks like we've got another question.
Yeah. If bikes are going through, we want to have do we want to have an offset from the barrier wall, or would we need a railing so they don't have issues with the through traffic?
Yeah, that's correct. Oh, sorry. Go ahead, David.
Go ahead. Go ahead.
Well, I was going to say I'm going to get to that a little bit, probably my next slide actually. But David, I think after I give this slide, it might be good for you to jump in, just because I feel like, you know, you've got some good insight too from Florida's perspective, correct?
Yes.
All right. So, you know, so when we talk about these marked bicycle lanes through DDI, and I, you know, general guidance is it's sometimes worthwhile to specify wider bicycle lanes to accommodate that horizontal curvature and still provide that lateral clearance to the center barrier. Also, enhanced markings such as the green paint, the dash skip lines, additional bicycle lane pavement markings may be necessary to reduce the confusion through the crossover intersection. And David, yeah, you went.
Yeah, we typically have a buffered bicycle lane that goes through there, so there would be two lines separating the bike from the travelway. And in some cases, there are some districts that are actually toying with putting a raised separator through there to actually give some physical separation between the bike and the travelway. But that isn't a standard for Florida. It's something that some of the districts are looking at right
Yep. So that sounds like it's still evolving a little bit.
now. Mm-hmm.
Yep. And so, you know, so this here is just an example of the enhanced markings for bicycle lanes. My recommendation would certainly be to work with the district and central office staff when looking at these, because some come with maintenance concerns. For example, the green paint looks great day one, but after a couple years, it wears off. You know, and do the maintenance staff really want to go back out there and paint green paint on the road? So those are the things to just be mindful of with respect to the maintenance. The second option for getting bicycles through a DDI is using a separate bicycle or multi-use path. And so for that one, let's refer to the FDM 223.2.4, separated bicycle lanes for more guidance, including appropriate widths. But the beauty of using separate bicycle facilities is that it can avoid what we call the keyhole issue, where bicycles can be trapped between the turn lanes and the through lanes for extended lengths, such as this image here. In this example, the bicyclist is in his own bicycle lane that is between the through lane and the dual right turn lane for nearly a quarter of a mile. This isn't always comfortable for riders and something that really should be avoided if possible. What gets worse is if one of these right turn lanes is actually an option lane, where a driver can either turn right or go straight. So if instead of a dual drop right turn, what if it was a right turn lane and a through right? Because this puts the bicyclist in a very bad situation, as they'd be trapped between two through lanes past the right turn diverge.
Yeah.
And so if you get a situation like that, or that what we call a keyhole, one option is to shift them to the wider sidewalk along the outside, as you can kind of see hopefully right here, and then cross the free flow ramp with the pedestrians. So you see that here as they're crossing that little green highlight, and then re-enter the bike lane prior to the crossover. So this is a good strategy to avoid that conflict area where either there's a keyhole or especially if there's an option lane, because that option lane becomes a real nightmare then to try to figure out how do you put your bicycles through it if you keep them on the road.
Yeah, if we do that, you need to make sure that your sidewalk is wide enough to accommodate both pedestrians and the bicycles. So it would be the criteria for a multi-use pad.
Yep, great point. And again, why we always talk about thinking early in the design, where are you putting bicycles, where are you putting pedestrians, because it could impact your overall width and your right of way. And then the third option is to allow the bicyclists to share the road with the vehicles through the DDI. But I need to stress that this should only be used in very low speed conditions. This is not a favorable condition at all. All right, I want to briefly touch on transit. There's not a lot of examples of DDIs with transit accommodations within them, so the guidance is pretty sparse on this subject. If including bus stops within a DDI, like this example in Colorado, there's many things that have to be thought about, including adequate sight lines, accessibility to the bus stops, reasons for why to include it in DDI core instead of the outside of the DDI, and etc. For this specific location, there's an extensive bus network and trails that come together at the interchange and several destinations adjacent to the interchange. But again, this is a very unusual circumstance. And there's a DDI in Minnesota that actually has light rail running through the center of the DDI. The geometric design considerations for a DDI with the center running light rail include, the crossover requiring longer tangent lengths to clear the rail line on a straight trajectory. Remember the need to extend the tangents through the crossover so drivers don't need to change the position of their steering wheel until through the intersection. Remember, we do this to avoid path overlap. Well, these tangents would need to be extended because the width of the intersection is greater with the presence of the light rail line. Also, the spacing of the crossover intersections needs to be long enough to store the entire length of the train unless the signal phasing allows the light rail to cross the entire DDI without stopping. So if there's a preemption in the signal, that can override it and for that short period, flash the all red for everybody else and allow him to go through. And again, this is an extremely unusual circumstance, but one I thought I would at least bring up. And just briefly, there's several additional DDI resources that are available, as I referred to a couple of these. First is, FDOT's own developmental design criteria for DDIs, D217. So that is available to you when you're designing your DDIs. The NCHRP 959, which is the DDI Informational Guide 2nd edition. This is FHWA's document. The document on the very right is the 1st edition, also very good, but as you can tell by the date of August 2014, it's outdated. So, there's some good information there, but I would recommend NCHRP 959 instead. There's a lot more material, especially on traffic operations and pedestrian facilities. And then there's several states that have done, kind of their either guidance document or lessons learned. So these are 3 examples, but if you just Googled others, there's plenty of states that have started to implement enough of these that they are now, believing that they have, understand the best practices and what they would do differently. And then just a quick reminder that 2 weeks from today is our last DDI webinar in this series. That one is going to be on plan detailing and public involvement. The content of that one's going to be tough to stretch into an hour, which is what that's scheduled for. So I expect that this will also be a little bit of a cleanup topic. So if you're reviewing some of the videos, hopefully that you, even if you missed, you were able to listen to. If you have any questions, don't hesitate to come and ask about anything that you have, even if it was about geometric design or traffic operations. I think that would be a good opportunity, I think, for the last 20 minutes, David, of that one to be a little bit of a cleanup session potentially.
Yep, that sounds reasonable.
Yep. So, and with that, I mean, I don't know if we have any additional questions.
Looks like we fielded all the questions. If there's any additional questions, key them in now. If not, I want to thank everyone for joining us, and hopefully you can make it for our next presentation. So I guess with that, that will conclude this webinar. Thank you.
Thanks, everyone.